right, Algebra 2, we are in Lesson 12. Oh, I thought I erased that. I wonder, because my little tablet thing that I write with is charging, if I'm going to have some lag, which is quite annoying, but let's see what happens. All right, in piecewise functions, we just finished domain and range, so today we are going to interpret, golly, a graph of a piecewise not settled. Interpret a graph of a piecewise function, or the rules, not on. Or the rules given in function notation. Okay, so we're interpreting graphs of a piecewise function or the rules given in function notation. Okay, and then we're going to be able to explain what those two things are with words. Explain the graph and the rules. Okay. So let's start with frozen yogurt, our warm-up. So a self-serve frozen yogurt store sells servings up to 12 ounces. It charges 50 cents per ounce for a serving between 0 and 8 ounces, and $4 for any serving greater than 8 ounces and up to 12 ounces. So you pay per ounce for 0 to 8 ounces, and then you pay a flat fee after that. Okay? Choose the graph that represents the price as a function of weight of a serving of yogurt. Be prepared to explain how you know. Okay, so 50 cents per ounce from 0 to 8 ounces, and then $4 for anything from 8 to 12. So let's get the highlighter out. So if we look, like this one right here, is that the right slope? So 1 ounce would be 50 cents, 2 ounces would be $1. So here we see just 50 cents per ounce from 0 ounces all the way up to 12 ounces. Okay, so that's not right. We're going to skip B. Here we see $4 flat fee whether you have 1 ounce in the cup or 12 ounces in the cup. That doesn't seem like a good deal. Here we see, let's see, I don't think our slope is right. So 3 ounces is $1. So that's not right. So our slope isn't right. Our price per ounce is wrong, which is our slope. All right, and then we have up here we have 50 cents per ounce from 0 to 8 ounces, and then $4 after that. So if you're getting 8 ounces of yogurt, you might as well get 12 ounces of yogurt because it's basically free. All right, so B is correct. All right, now let's look at what we see here. This graph right here is called a piecewise graph. It's broken. It's in pieces. It's like a puzzle that you puzzle together. Right? In the past, I've called it a step because it looks like you could put a little person on here and that little person could climb the steps. Right? Why did my person get smaller with each step? I don't know. But it's a piecewise graph. Okay, so let's talk about this one. The relationship between the postage rate and the weight of a letter can be defined by a piecewise function. The graph shows 2018 postage rates for using regular service to mail a letter. What is the price of a letter? Well, first let's look at the graph and what we see here. Actually, pause. I'm going to go up and talk about this again. Yeah, let's do that. We're going to talk a little bit more about B because B is correct. I could actually write an equation for this line right here. it would be the cost as a function of weight is equal to 0.50 times W. And then I could write an equation for this line. I could say that one is the cost as a function of weight is equal to 4. Okay, but what's really important here is this first equation only applies when our weight is between 0 and 8 ounces. And this equation only applies when our yogurt weight is between 8 and 12 ounces. And we'll get into the 8 and why 8 has to go with either one equation or the other. It can't go with both. But we really have two equations here. So when I said what we're going to do is interpret a graph of a piecewise function or the rules given by the function, here we have the graph and here we have the rules. And both of them are very, very important. When we talk about the rules, we really need to state what our domain is. 0 is less than weight is less than 8 ounces. And we're going to say 8 ounces goes there. And then here, our weight, 8 is less than weight is less than 12 ounces. And we're going to make the 12 part of that. So we have to do a domain restriction for each equation. All right, let's move on. All right, so here I've got this piecewise graph. You see how they're not connected though, unlike our yogurt example where they were connected? What's really important here is our input of 0 weight is not a part of the graph because it's an open circle. Our input of 1 ounce is a part of this line and not this line. Not that line. Our input of 2 is a part of this line, but not that line. I guess we could just go like that. Makes sense? Same with 3. It's a part of this line, but not that line. I'm going to erase that because that's going to confuse us as we move on. All right. So what is the price of a letter that has the following weight? If we do 1 ounce, our input is 1 ounce. Our output, I hit this dot, our output is 50 cents. When our input is 1.1 ounces, which is somewhere around there, we go up, we hit this line, and then we go over and we read, it's actually 0.71 cents, 71 cents. So here we hit the line here and we read 50 cents. We hit the line here and we read 75 cents. And then 0.9 is a little less than 1. So here we hit that line and we go to 50 cents again. Right? So that's reading our graph of our piecewise function. Okay, we find the input that they're asking about and read the output. We find the x, or the horizontal input, and read the vertical output, the domain and the range. So a letter costs 92 cents to mail. How much did the letter weigh? So this right here is the output, the range. So let's go read. There's 92 cents. We're going to come over. Well, we're not sure. 92 cents is anywhere between 2 and 3 ounces. So the letter weighs more than, oh my goodness, more than 2 ounces and all the way up to equal to, or, my goodness. I don't know why it's so hard this morning. So more than 2 ounces all the way up to equal to or less than 3 ounces. So how we would do that in interval notation, we would say 2 is less than weight is less than or equal to 3. Anywhere between 2 and 3 ounces. You can't include the number 2 because the number 2 ounces goes down to 0.71 cents, 71 cents. Where 3 ounces is the 92 cents, right? So the letter weighed somewhere between 2 and 3 ounces. Can't be too exact, it can be 3. All right. So here we have Karen and Mai wrote some rules to represent the postage function, but each of them made some errors. Let me make this a little bit smaller because I want to see it. Identify each error and identify the error in each person's work and write a corrected set of rules. Well, right here is the interval notation that we just talked about in number 2. Okay, right there. So we know that our outputs are 50 cents, 71 cents, 92 cents, and $1.13. And this right here is our inputs, our domain. So between 0 and 1, we're at 50 cents. Okay, 0 and 1 is 50 cents. Right there, that was our mistake. That right there is an open dot at 0, and this says less than or equal to. Well, that should only say less than. That equal to symbol should not be there. And then if you look at 71 cents between 1 and 2 ounces, 71 cents between 1 and 2 ounces, well, it's not at 1. I cannot include 1 in that domain. So that needs to go away. It's between 1 and 2 ounces. Same with 92 cents. 2 cannot be a part of the solution, or it's part of the domain, cannot be part of the input. So I need to get rid of that. Okay, so those should just be less than signs, not less than or equal to. All right, so Kieran was close. Mai is also close. What do we see with her mistakes? I've got 0 to 1 ounces is 50 cents. 0 to 1 is correct, but I need to include the 1. I need to include the 2. I need to include the 3 and the 3.5 because those are all closed dots, so they need to be included in the domain. And by including them, I put an equal to symbol there. All right, good job. Let's talk about bike sharing. Function C represents the cost, the dollar cost of renting a bike from a bike service, sharing service for T minutes. Here are the rules describing the function. So $2.50 for 30 minutes. 30 more minutes is $2.50 more. $5, $7.50 in the next 30 minutes. So we've got 30-minute increments and $2.50 more each time, except this last one, 150 to 720 minutes, which this is 12 hours. That's just that big block at the end. So $15 basically all day, okay? Complete the table with the cost for the given sketch and graph. Complete the table with the costs for the given sketch. Given lengths of rental. This right here is a break. That's hilarious. And then sketch a graph of the functions. So here, let's do our input. This is our input, our range. If our input, our domain. If our input is these t values, what is our output going to be? So just go here and read the domain, read the inputs. So when time equals 0, 0 is not a part of this function, so our cost is going to be 0. Okay, 10 minutes is in that first interval. 25 minutes is also in that first interval. 60 minutes is included in the second interval. 75 minutes is included in that third one. 130 minutes is right in there. $12.50. And then 180 minutes is $15. So you're just finding where do these fall in that interval, in that list of intervals over there, okay? So in function, that is our piecewise function rules. They're all written like number sentences. But let's go ahead and try to put these into a graph. They didn't give us a graph in this one, but we can make one. So I know for 0 to 30, not including 0, but including 30, I did not put that at the right spot, it's $2.50. And then for 30 to 60, not including the 30, including the 60, it's $5. $7.50 for the next 30 minutes, $10 for the next 30 minutes, $12.50 for the next 30 minutes, and then $15 for the remainder. Okay, they've only given us up to $2.40, so don't put an arrow. If you want to be exact, you can do that. 720 minutes, just extend your graph. But describe in words the pricing rules for renting a bike from this bike sharing service. So describe in words, I would say $2.50 per 30-minute increments, up to a maximum for 12 hours. Okay, that would be in words. Now, determine the domain and range of this function. Now, if we look at it, we've done this in the past. Our domain is right here. Extended a little bit to get that 720. So we're going to say the bikes can't be rented for more than 720 minutes or 12 hours. The domain includes, I can just go like this. Oops, 720. Or I can say any time between 0 and 720 minutes. Okay, we don't even have to state the 30-minute increments. So that's our domain. I didn't write that down. And then our range. So our range is here, but we need to be careful and talk about the $2.50 multiples. So I'm really going to say multiples of $2.50 up to $15. We want to make sure that we don't include all dollar amounts between $2.50 and $15 because you're never going to spend $3. You're never going to spend $5.50. You're only going to spend multiples of $2.50 up to $15, right? You'll never spend $0 because you didn't rent a bike. Okay, I'm going to do this tomorrow. Not tomorrow. During your lesson, the next day I see you in class, we're going to do this in class together because it says I will give you strips of paper with parts of graphs. All right, so we're going to do this in class. And that's it. Good job today.